Here we have a problem on derivative. That is, we have to find the derivative of this function with respect to x. Here on the left side, we have y. If I find derivative of this y with respect to x, I'll be getting dy over dx. So how do you have to find the derivative of the stuff on the right side? Here there are two terms, both the terms are multiplied. Okay, here in the first term 2 to the x power contains the variable x and the exponent. So the second term x to the fifth power also contains x. So here both the terms contain the variable x. If when two terms are multiplied and only one of the terms contains variable and the other term is a constant, so we can easily find the derivative. But here the two terms are multiplied and both the terms contain variable. So what do we have to do? So before finding derivative, we should try to multiply these two terms and simplify. But it's not possible because we cannot multiply and simplify 2 to the x power and x to the fifth power. So the other option what we have is we have to use the product rule to get derivative of this one. Okay, now first let me get the derivative of this y with respect to x. It will be dy over dx on the right side. So to get the derivative of the product of two terms where both the terms contain variable, we have to use product rule. So the product rule is consider the two variables u and v. So assume both u and v are variables. I want to find derivative of this product u and v. So for that, what I need to do is I have to keep the first term as it is and find the derivative of the second term v positive. Then now I have to find the derivative of the first term u. I have to keep the second term as it is. So this is called product rule in derivative. Okay, now I'm going to use this product rule in our problem. So I consider this is u and this is v. So in my first step, what I'm going to do is I'm going to keep u as it is, that is 2 to the x power as it is. I have to find the derivative of the second term, that is x to the fifth power. Now I have to find the derivative of the first term 2 to the x power. I have to keep the second term as it is. Okay, here dy over dx equals to 2 to the x power. So how do you have to find the derivative of this x to the fifth power? We just have to use the power rule of derivative. What is power rule of derivative? Consider x to the nth power. So I want to find derivative of this x to the nth power with respect to x. So what I need to do is I have to bring this exponent in front of the variable and subtract 1 from the exponent. So this is the power rule of derivative. So now x to the fifth power is exactly in the form of x to the nth power. So I can use the power rule over here to get the derivative of x to the fifth power. So I have to bring this exponent 5 in front of the variable x and subtract 1 from the exponent. Positive. Okay, how do you have to get the derivative of this 2 to the x power? Can I use the power rule? No, I cannot. So because the power rule can be used only if you have variable at the base and constant at the exponent. But here we have constant at the base, variable at the exponent. So to get the derivative of this 2 to the x power, we have to consider the stuff a to the x power. So here the base is a constant and the exponent is variable. So whenever I want to find derivative of such a stuff, that is the base is constant and exponent is variable. So its derivative is, we have to write this a to the x power as it is, and it has to be multiplied by natural logarithm of the constant of the base a. Okay, what is the derivative of the 2 to the x power? So this is also in the form of this. So the base is a constant and the exponent is a variable. So to get the derivative of 2 to the x power, we have to write this 2 to the x power as it is times ln, whatever constant we have at the base should be written over here. So that is 2. So the derivative of 2 to the x power is 2 to the x power times ln 2. So that I can write for the derivative of this 2 to the x power. So I'm getting 2 to the x power times ln 2, and apart from that we have x to the fifth power. Okay, almost we got the derivative of the given function with respect to x. So 2 to the x power times 5 times x to the, when I simplify this 5 negative 1, it will just become 4 times 2 to the x power times, we can write this x to the fifth power over here because all of them are in multiplication. So 2 to the x power times x to the fifth power times ln 2. So dy over dx equals to, so what can be factored out from these two terms? So I find 2 to the x power in common. I find x in common, but here we have x to the fourth power, here we have x to the fifth power, but we can factor x to the fourth power because we find x to the fourth power in this one, we find x to the fourth power in common. So we can factor 2 to the x power times x to the fourth power. So if 2 to the x power and x to the fourth power is factored out, we have 5 left in the first term. The second term, 2 to the x power is factored out, but this x to the fifth power can be written as x to the fourth power times x. If x to the fourth power and 2 to the x power are factored out, we just have left x and ln 2 in the second term. So we get in the second term, we have x times ln 2. So this is the derivative of the given function with respect to x.